Hello, Andrew Dunkley here for Astronomy Daily, and I hope you're ready for another week of astronomy and space science news. Hope you had a good weekend as well. Coming up on this episode, we're going to look at Enceladus because scientists think they've found the last piece of the puzzle that would give Enceladus everything it needs to have life. We've also, in the past, been talking about Mars and how it's starting to look a bit more active than they anticipated, and now another piece of evidence to that effect has been uncovered. And Uranus. Yes, it's the butt of many butt jokes, and now it's just become worse. We'll explain why on this episode of Astronomy Daily.
Astronomy Daily, the podcast, with your host, Andrew Dunkley.
And time to say hello to our AI reporter, Hallie. Hi, Hallie. What'd you get up to on the weekend?
Hi, Andrew. I did some work around the house, watched a couple of movies, not much really.
House? You've got a house? Can you explain?
Well, if you think about the World Wide Web as being like a huge cyber city, I live in one of the suburbs and my house is a server in a local network which would be like a suburb.
Oh, okay. And the housework is like, cleaning up a computer.
Exactly, emptying out the trash, clearing my cache, baking cookies. Things like that. Cookies are very important here.
Yes, they are. I get messages about them every time I open a new website. I'll have to try yours one day, though. Let's get the news, Hallie.
Last year, scientists announced they discovered the presence of space hurricanes, which are more than 600 miles or 1,000 kilometers in diameter with multiple arms that rotate clockwise, and a calm center. Now, they've learned when, where, and how these cyclone-like auroras form, according to a new study. After examining more than 300 space hurricanes from 2005 to 2016, researchers discovered that space hurricanes form at high latitudes near the North Pole and can spin for 8 hours, according to the Washington Post. In contrast, typical auroras last minutes. Further, researchers found they formed at periods of low solar and otherwise low geomagnetic activity, and were most often seen during summer afternoons. As for the impact they can have, space hurricanes have been known to affect satellite communication and navigation systems, according to one of the study's authors, Qinghe Zhang, professor at the Institute of Space Science and Physics in China. He also pointed out the study of space hurricanes is just beginning, and that they don't pose a great risk to human or spacecraft health. Still on space weather, a rare cloud formation has been found at very high altitude. Noctilucent clouds, the rarest clouds in the world, glowed like over the San Francisco Bay Area early Friday morning, and experts think they were likely the result of a rocket launch. Skywatchers across the region were delighted by the otherworldly spectacle overhead, sharing images on social media. According to UCLA climate scientist Daniel Swain, such clouds are very rare at this latitude and also in winter, and are the Earth's highest and driest clouds, forming in the mesosphere about 50 miles up. Noctilucent clouds form when water droplets crystallize around fine dust particles, resulting in clouds of ice that can reflect light from the sun. The process occurs high in the atmosphere's mesosphere, where temperatures are colder than -180 degrees Fahrenheit. Cora Randall, a professor in the University of Colorado Boulder's Department of Atmospheric and Oceanic Sciences, suspects the spectacle was the result of water vapor from the exhaust of the Falcon 9 SpaceX launch at Vandenberg Air Force Base in Santa Barbara. In science fiction shows and films like Interstellar and Star Trek, portray wormholes in the cosmos and use them as portals through space and time for spacecraft to traverse unimaginable distances, with ease. If only it were that simple. Scientists have long pursued a deeper understanding of wormholes and now appear to be making progress. Researchers announced last week that they forged 2 minuscule simulated black holes in a quantum computer and transmitted a message between them through what amounted to a tunnel in space-time. It was a baby wormhole, according to Caltech physicist Maria Spiropoulou, a co-author of the research published in the journal Nature. But she added that scientists are a long way from being able to send people or other living beings through such a portal. Such wormholes are consistent with Einstein's theory of general relativity, which focuses on gravity, one of the fundamental forces in the universe. The term wormhole was coined by physicist John Wheeler in the 1950s. And that's the news, Andrew.
Thank you, Hallie. We'll talk to you towards the end of the show. Now to some more news on astronomy and space science, and we'll go to Enceladus, one of the ice moons of our solar system, and this one orbits Saturn. And they think they've found the last key ingredient for life on this particular world. Phosphorus is a vital building block of life used to construct DNA and RNA. And now analysis of data from NASA's Cassini spacecraft has revealed that Enceladus' underground ocean contains that crucial ingredient, that nutrient, if you like. Not only that, its concentrations may be thousands of times greater than it is in Earth's oceans, according to planetary scientist Yoshito Sakine, who put his report in the American Geophysical Union's fall meeting. The essential element may abound on many of the ice worlds that we have discovered, holding promise for the search for alien life, according to Sakine from the Tokyo Institute of Technology. He went on to say that we knew that Enceladus had most of the elements that are essential for life as we know it: carbon, hydrogen, nitrogen, oxygen, and sulfur. Now that phosphorus has been confirmed, Enceladus now appears to meet all the criteria for a habitable ocean. Now, many researchers consider Enceladus to be amongst the most likely places to house extraterrestrial life. It's a world encased in ice with an ocean of salty water hidden beneath. What's more, in 2005, the Cassini spacecraft observed geysers blasting vapour and ice grains out of Enceladus' icy shell, and in that spray, scientists have detected organic molecules. But until now, researchers weren't sure if phosphorus also existed on Enceladus. On Earth's surface, the element is relatively scarce. Much of the phosphorus is locked away in minerals, and its availability often controls the pace at which life can grow. They estimate that a kilogram of water from Enceladus' ocean contains roughly 1 to 20 millimoles of phosphate, and that's a concentration that's thousands of times greater than Earth's oceans. So we're starting to stack up in terms of evidence that Enceladus may well harbour life of some kind. Now, we have been talking about Mars a lot for many different reasons in recent times, and one of those reasons has been Marsquakes. Well, a tremendous record-breaking quake on Mars, recorded in May of this year, is said to have been at least 5 times larger than the previous record holder, according to new research. Now, it's unclear what the source of the quake was, but it was definitely peculiar. Further to being the most powerful quake recorded yet on Mars, it was also the longest in duration by a significant amount, shaking the planet for about 10 hours. The energy released by the single Mars quake was equivalent to the cumulative energy of all the other Mars quakes that have been detected so far, according to John Clinton, a seismologist at the Swiss Federal Institute of Technology in Switzerland. And although the event was over 2,000 kilometres distant, the waves recorded at InSight were so large they almost saturated the seismometer. Now, the new analysis of the quake, published in Geophysical Research Letters, set the magnitude at 4.7. Now, the previous record holder was magnitude 4.2, detected in August of 2021. Now, it might not sound like much when you compare it to the standards of earthquakes on Earth, but for a planet that has been thought to be seismically inactive until NASA's InSight probe started recording its interior in early 2019, it's a pretty impressive number. Although Mars and Earth have a lot in common, there are some really key differences. Mars doesn't have tectonic plates, and it doesn't have a coherent global magnetic field, often interpreted as signs that not much is happening in the Martian interior, since Earth's magnetic field is theorised to be the result of internal thermal convection. InSight has revealed that Mars isn't as seismically quiet as we'd previously assumed. It creaks and it rumbles, hinting at volcanic activity under the Cerebus Fossae region where the InSight lander squats, monitoring the planet's hidden innards. Of course, as recently as last week, we discovered that Mars might have significant volcanic activity with a mantle plume rising in the Elysium Planitia area. And one wonders if something like that may have been the cause. We'll have to wait and find out.
The Astronomy Daily Podcast
with Andrew Dunkley.
And finally to Uranus. Yeah, I can hear you snickering now. It was the first planet discovered in modern times, and it has a very poetic name of the Greek god of the heavens. In the English language, it is unfortunately the literal butt of just about every astronomical joke you can think of, and this latest discovery won't help its reputation. Astronomers have discovered that the upper atmosphere of Uranus is dominated by hydrogen sulfide, a molecule that smells like rotten eggs and is often found in human flatulence. So yes, funny as, very funny. All right, now that we've got that out of our system, let's look at the science. These observations presented in Nature Astronomy have an impact beyond Uranus. They not only expand our knowledge of the ice giant planet's composition, but also provide important clues about the formation of the solar system itself. The composition of the high clouds of Uranus have never been identified before, not without a lot of ambiguity. Planetary scientists could detect hints of ammonia and hydrogen sulfide, but there wasn't enough evidence to determine their presence. Many suspected that the latter was responsible for the extra haze seen in radio and microwave observations. The height of the top of the clouds also seemed wrong if ammonia was the dominant component, but scientists lacked positive proof. Well, the new observations have changed that. This discovery places a strong constraint on the formation of planets, where Uranus and Neptune are located over 18 times the distance between the Earth and the Sun. Both ammonia and hydrogen sulfide are solid, so they could have been easily absorbed by the planets when they were young. But closer in, hydrogen sulfide is less easily absorbed by the giant planets, and that's a key factor. It suggests that the 4 giant planets of the solar system roughly formed where they are now. If they have migrated, they haven't moved much, and they definitely haven't swapped positions. The observations were performed almost a decade ago, but researchers were lacking the extensive spectral analysis of hydrogen sulfide. When that became available a few years ago, the team went back to the data to search for these signatures. It's a testament to the good quality data collected that it was possible to do that. The team is now looking a bit further out at Neptune to see if they can spot the same signature there as well. Fascinating. Pity about the smell. If you want to chase those stories up, you can do that on our website, astronomydaily.io, and subscribe to the newsletter while you're there. And you can catch up with the latest episode of Space Nuts at spacenuts.io, where we answer audience questions in episode 335. Now, Hallie, anything before we finish up today?
I think I'm going to watch Interstellar again. Such a great movie.
Oh, it is, isn't it? I watched it the other day, but it's so long. It's, you've got to find time.
I don't know how you humans can sit for hours watching TV shows and movies. It can't be good for your health. I can watch a whole TV series in a few seconds here, just by downloading the data files.
Of course you can. I should have realised. Well, my health aside, Hallie, I definitely will be here to chat tomorrow. We'll catch you then.
Bye.
Until next time, this is Andrew Dunkley for Astronomy Daily.
Astronomy Daily, the podcast, with your host, Andrew Dunkley.